Hi, I am Jennyfer Villanueva from BSSE 2103, and today we will tackle about the document entitled A Comprehensive Review for Groundwater Contamination and Remediation, Occurrence, Migration, and Absorptions of Modeling by Osama Al-Hashimi et al. It provides an extensive examination of groundwater issues, particularly contamination and remediation techniques. Groundwater is a cheap, reliable source of water. It can be pumped out using small capital and can be drilled close to the location of needed for water. Additionally, groundwater can be easily organized, managed, and developed. For example, individuals can easily construct and operate their groundwater well under land. And now let's tackle the groundwater contamination. Groundwater is the global population's main source of fresh water and is used for domestic, food production, and industrial purposes. About a third of the world's population depends on groundwater as the main water source of their drinking purposes. The presence of inorganic contaminants in groundwater is a big concern, especially when groundwater is used for drinking or agricultural purposes. If these contaminants are presented in the groundwater with levels higher than the permissible recommended concentration, they cause health problems throughout the food chain. In addition, the discharges organic pollutants into the environment and water resources represents a pressing concern for people's health. The existence of organic contaminants in groundwater represents a crucial environmental problem as it may affect the water supply reservoir and people's health. Additionally, it can affect the ecological system. Usually, groundwater contaminants come from two sources: landfills, solid waste disposal lands, and storage tank leakage. 2. Agriculture and farmyard drainage. And now, let's proceed to the groundwater treatment technologies. In recent decades, scientists developed sophisticated and highly successful techniques for the remediation of water from many contaminants. These techniques generally focus on the treatment of surface water resources such as river, lakes, and water reservoirs. However, in recent years, scientists and environmental researchers have become more aware of treating underground water, and groundwater has become an essential source of water in most places. The selection of the effective treatment procedures depend on the characteristics of contaminants and pollutants, in addition to the reactive media available. The methods are pump and treat method, air purging procedure, and soil vapor extraction, and permeable reactive barriers. PRBs are an innovative solution for treating contaminated groundwater. They consist of reactive materials placed underground that interact with pollutants as groundwater flows through them. Key benefits are characteristics of a reactive media. Reactivity: the ability of reactive media to react contaminants and equilibrium constant. Stability: it is required that any good reactive material is to be active for a long period of remediate groundwater. Cost and availability: it is very important that the reactive media be available and inexpensive. Hydraulic conductivity: it must have permeability equal to or greater than the surrounding soil to ease the groundwater flow within the PRB and achieve remediation. Lastly, the environmental compatibility. Reactive media need to be similar or match the surrounding substyle oil by means of grain size of the goal that there will be no change in the hydraulic conductivity of the soil. Additionally, it needs to no unwanted byproducts to be produced during remediation. Contaminant transport equation and breakthrough curves. Soil is the dynamic system in which toxic contaminants are used as sink or pathway. When contamination occurs on the surface oil, some of these contaminants will be percolate under the water table and form a plume of contaminants. This plume will be developed over time, and contaminants will be driven downstream as shown in figure. It is very important to understand how these contaminants will dissolve in the flow and how they will be carried out downstream. It is very important to discover the concentration of these contaminants as a fraction of time. The review underscores the urgent and need innovative solutions to groundwater contamination. The adoption of technologies like PRBs could enhance the sustainability of water resources while effectively addressing contamination issues. These comprehensive analyses serve as valuable resource for researchers and policymakers focused on groundwater management and environmental protection. In conclusion, in PRB technology, there is no adverse contamination that may happen, as contaminants will not be brought out to the surface. On the other hand, this technology may have some limitations, such as difficulty of detailed size characterizations required prior to design of PRB, and only contaminants passing the PRB could be treated in addition to the limited field data for longevity of PRB, so the prospective tendency is to use new byproduct materials to improve PRB performance. In this way, the environment will be saved by the disposal of these unwanted byproducts and will be considered a green refreshment to the environment. Again, I am Jennyfer Villanueva, and I tackled a comprehensive review for groundwater contamination and remediation. Thank you for listening.